Hey guys, so for this video tutorial I will be teaching you one of the concepts in chapter 7. This will be 7.1. So in this video about 7.1 there is a list of things that I'm going to show you how to accomplish. First, we're going to graph using a table of values, then find the values where each real zero is located, then see the x-coordinate where the relative minimum and maximum occur, then find the leading coefficient, and finally determine the long-term behavior. Let's get to it. Alright, so let's start off with an easy one. So for the first one we have f of x equals x cubed minus 3x plus 1. At first you might be not sure where to start, but I always think that it's helpful to go from negative 3 to positive 3. This won't always be the case, but in the beginning that is a good range of numbers to start with. But thankfully, we have our calculators to help us start. After taking the results from your calculator and putting them on your sheet of paper, you can then begin to graph. Now that we've completed step 1, we now get to find the x values where all the zeros are located. In this problem, there are going to be 3 zeros because there are 3 points on our line that cross the x-axis. Since none of the zeros hit exactly 1 point on the x-axis, we are allowed to say the 2 whole integers which they are in between. So for this one, we'll be between -1 and -2. For the next one, it is in between 0 and 1. And finally, for the last one, it is in between 1 and 2. That is step 2 all complete. You can see your minima and maxima in 2 different ways. You can see it in the graph physically, or from your x and y values. So the maxima will be right in between here, because you can see it goes from -1 up to -3, back down to 1. So that is your maxima. Then you can see how it goes from 1, decreases to -1, but then goes back up to 3. This will be your minima. So when you look at the chart coordinates, you can then see when x is 1, that is where your minima occurs. So then you'll fill in 1. Then your maxima occurs on the x value of -1 up here. So that is your maxima, -1. That is step 3, all completed. Then we get to figuring out what the leading coefficient is. You might be not sure how to do it because there is a bunch of changes of direction. But in reality, you just think of it as if there was one simple line going like this, it will be going from left to right in an upward direction. What does that mean? That means that the leading coefficient will be positive. So now we have come to our final step, and that is determining the long-term behavior. When determining long-term behavior, we always start off with this setup. So this just means that as x goes positively this way, we have to determine what way the y will go. And then the opposite is for this. As x goes infinitely negative, we have to determine which way the y value will go. So for this one, as x goes this way, the line ends with y going upwards. So then that means f of x goes to positive infinity. Then for this one, we see as x goes infinitely to the left, the f of x or y is infinitely going down or negative. So then that end behavior will look like this. Do you think you understand how to do the things in 7.2? If not, that's okay, because we're going to hop into another example that'll hopefully clear up any questions that you have. Let's get to it. Next, we're going to try to do a little bit of a harder problem. So personally for me, when I see decimals in a long line of numbers, I get nervous. But we're just going to follow the same exact steps as we did for the first one. Let's get to it. So, once you plug it into your calculator, you can see that our method of going from -3 to +3 still works. So let's write that on our piece of paper. When you plug in the x's, some of the y values that you get are decimals. You don't have to worry about this, just think of them as their normal numbers and plot them like you would usually do. When you finish plotting your points, you should get a chart that looks something like this. If you come across a difficult problem and you're not quite sure of yourself, you can always go to your calculator and hit the graph button. Then your calculator will draw out what the chart should look like, and if you double check with yours and it looks the same, then you're all set. Then, when looking at the graph, you can see that the first real zero is between -3 and -2. And then the second and final zero, right here, is between -2 and -1. This also shows that even though you might have a change in direction, that does not mean that it has to touch the x-axis and be a 0. In this problem, I'm going to start off with finding the maximum. So we can see both from our chart and our graph that the maximum will be at the x-coordinate of 0. Then here comes a little bit of a tricky part. There are actually two minimums in this chart because these are the two spots where it goes down and then upward again. So these minimums will be at -2 and +1. For this problem, it is not as clear-cut to see the leading coefficient, but since they are both heading in a positive direction, the leading coefficient would also be positive. Finally, we get to determining our long-term behavior. So, as x goes positive to infinity, we also see, just like in the last problem, that the f of x or y also goes positively in the upward direction. So that is the positive infinity. But then the change comes in the next one. So as x goes to -infinity, this time the f of x also goes positively upwards. So then that is another positive infinity. So what I'm going to leave you with here today are 5 problems that you can go and do on your own. Don't forget the 5 main steps. Graph using the table of values, find the x value or values where each real zero is located, determine the x-coordinate or coordinates where the relative minima and maxima occur, find the leading coefficient, and state the long-term behavior. So I know this probably wasn't as fun or interesting as like a David Dobrik, Shane Dawson, or James Charles video, but hopefully I, Sara McDougall, taught you or now you better understand chapter 7.2. See you in class. Wait, Sarah, so you're going to give them practice problems and not even show them what the answers are? Oh my god, I almost forgot. Sorry guys, I'll leave a few pictures of the problems right after this clip. No peeking and good luck.